Assalamualaikum and hi. Today we want to present Predictive Analytics Assignment 1. This assignment prepared by Patricia Humaira, Alia Shahdina and Haifa Patricia. So this is our data overview before. Assalamualaikum, my name is Alia Shahdina binti Muhammad Fairuz. My matric number is 306506. So now I want to explain the coding based on our data set. First, import the libraries and set styles for visuals. Next, print a header title of a student admission data pre-processing and print the section title for step 1, load dataset and display sample records. Next, loads dataset by reads the CSV file into a pandas data frame called TF. Shows the dataset dimensions in the form of number of rows and number of columns using df.shape. So the output will be produced like this. Data shape, colon, 157,7 means 157 students records for row and 7 features for columns. Next, display the first 10 records of the dataset. Use df.head bracket 10. df.head used to visually inspect the structure and spot missing values. The output shows that there are missing values, none, in admission status, admission test score, and high school percentage. Next, display dataset information that shows number of row and columns, column names, data type, non-null values for missing value detection, and memory usage by use df.info bracket. Based on the output, there are some values are missing and data type float 64 means numerical values and object means text or categorical data. Next, for missing value coding and output, first, prints a heading for step to handle missing values. Next, show missing values before cleaning. Use df.is null bracket to check each value in the dataset. Return true if value is missing, none, false if otherwise. Use .sum bracket to count how many true values in each column. Missing underscore before stores the number of missing values per column. Next, create a copy of the dataset. Creates a full copy of df so that the original dataset stays safe and all cleaning is done on df_clean. Next, remove rows with missing names. Drop null bracket, remove rows with missing values and subset equal to name means remove only row where name is missing, because a student record without a name is not useful. Next, fill missing numerical values using median. First, define numerical columns. Create loop through each numerical column. Use median bracket to find the middle value of the column. Fill missing values none with that median value. We use median because median is less affected by outliers than the median. Next, fill missing category values using mode. For data categories, you cannot use mean or median. Use mode bracket to find the most frequent value. Square bracket 0 select the first most common value. All missing values will be replaced by the most common category. Next, predict missing admission status. First, define a custom function to handle missing admission status. If the status is missing, if test score greater than 70 and high school percentage greater than 75, it will be accepted. Else, it will be rejected. If not missing, return original value unchanged. Apply the function to all rows. Use apply bracket to apply your function row by row. Axis equal to 1 means row-wise. The result replaces the admission status column. Next, show missing values after cleaning. Check missing values again, and now the output should show 0 missing values in every column. So based on the output, all missing values have been successfully handled. Next is coding to detect and remove outliers. First, print title for step 3, detects and remove outliers. Next, use the IQR method for outlier detect function. Q1 equal to 25th percentile, Q3 equal to 75th percentile, IQR equal to Q3 minus Q1. Measure spread of middle 50%. Lower equal to Q1 minus 1.5 times IQR. Upper equal to Q3 plus 1.5 times IQR. Define standard IQR threshold. Returns Boolean mask true for outliers, lower and upper. Next, prepare for analysis by print outlier analysis. Outliers underscore remove will accumulate number remove. df_no_ outliers is a working copy. Next, create loop through numerical columns. Applies the function on each numerical column, age, admission test score, and high school percentage. Next, display the outlier info. Outliers.sum bracket counts how many values are true. This means how many outliers were found in that column. Next, remove outliers. Tilde outliers means no outliers. It keeps only normal data. Remove rows containing outliers. Reset underscore index drop equal to true resets index numbers properly after row deletion. Outliers are removed column by column, which might remove the same row multiple times if it has multiple outliers. Next, count total outliers removed. Adds up the outliers removed for each column. Display total number of removed outliers across all numeric columns and shows how many records are left after cleaning.
Assalamualaikum warahmatullahi wabarakatuh. My name is Haifa Batrisha binti Syaiful Zaidi. My metric number is 306646. So today I will explain to you about data integration. First of all, we start by printing the title data integration, followed by a separator line for clear section identification. So we create additional data using a dictionary containing 3 new pieces of information. Student ID, that is unique identifier for each student from 0 to 138. Second is extracurricular underscore score equal to extracurricular activity score from 1 to 9. Then interview underscore score equal to interview performance score from 50 to 69. So how the computer does it? First, as we can see, range bracket length, bracket df underscore no underscore outliers, bracket to create sequential IDs 0, 1, 2, 3 until 138. Second is mp random dot reading bracket 110 left length bracket df underscore no underscore outlier bracket to random score from 1 until 9 for 139 students. Lastly, np.random.random 100 length bracket df underscore no underscore outliers bracket to random score from 50 to 99 for 139 students. So next, for df additional equal to pd.dataframe bracket additional underscore data, we convert this dictionary into a pandas data frame with 3 columns and 139 rows. The integration process is done in 3 steps. First step, reset underscore index bracket drop equal to true bracket dot copy bracket. It reset index to organize sequence 0, 1, 2, 3 and so on. Also, it create independent copy of original data. Second step is df underscore integrated subset operator student ID equal to df underscore additional subset student ID. This is for add student ID as a new column to the main data set. Each student gets their unique identifier. Last step is pd.concate bracket as is equal to 1 close bracket. It's combine original data with the 2 additional scores horizontally. Original data is 8 columns plus students ID 1 column plus 2 new scores is equal to 11 columns total. We print confirming showing that has 2 new features successfully added. Student ID was also integrated, but 2 not explicitly mentioned in print. So we have current dataset size is 139 rows and 10 columns. For the next part is data transformation. So for the print, we need to clear section header for data transformation processes. So first of all, in the coding, df underscore transform equal to df underscore integrated dot copy bracket is create a working copy to preserve the original integrated data. Next, we go to label and coding process. In the coding, categorical underscore to underscore anchored equal to subset operator, gender, city, admission status, and close subset operator. Label underscore encoders equal to curly bracket and curly bracket. This part of coding, we identify 3 categorical variables for conversion to numerical format. For the next coding is for call in categorical underscore to underscore anchored. As we can see in the coding, this is about the loop execution for each category. Iteration 1, that is gender, to create encoder, convert male or female to 1 and 0, add a gender encoded column, print mapping, that is female equal to 0 and male equal to 1. For second iteration, that is city, it converts city names to number, print mapping, Islamabad equal to 0, Karachi equal to 1, Lahore equal to 2, and so on. For third iteration, that is admission status, it converts status to numerical values, pre-mapping accepted equal to 0 and rejected to equal to 1. So for the next part, that is standardization process. As we can see, we use scalar equal to standard scalar bracket. We prepare scalar and identify 5 numerical variables for standardization. Student ID is not standardized because it's identifier, not a measurable feature. So, standardization process. First, for each of the 5 numerical columns, we need to calculate mean and standard deviation. We use formula Z equal to bracket X minus mean, close bracket, divide standard underscore deviation. Second, we convert all values to Z scores, and the result is standardized column has mean equal to 0, standard deviation equal to 1. Example transformation. For example, original age is equal to 20, 22, 19, and 25. After we convert to standardized age, it's going to be negative 0.6, 0.2, negative 1.0, and 1.4. So after that, we confirmation message showing standardization completed successfully.
Hi and Assalamualaikum. My name is Patricia Humaira Fakri and my metric number is 306573. Today, I will present about data reduction. To reduce complexity, we apply feature selection and principal component analysis, or what we call is PCA. We retain the most meaningful feature and reduce dimensional while maintaining essential information. PCA produces 2 major components that capture 56% of the total variance, which is sufficient for visualizing patterns and maintaining analytical accuracy. Next, I will represent descriptive statistic comparison. We compare descriptive statistic before and after processing. Originally, the data set the inconsistent range as the outlier, missing value. After pre-processing, the data set becomes standardized, balanced, and ready for accurate modeling. For visualization, we generate several visualizations, including distribution plot, box plot, and heat map. This visualization help us identify outlier, analyze correlation, and understand how a feature behaves after transformation. We also use PCA plots to observe data clustering and feature relationship. So, I will continue for the distribution and the box plot. The visualization show the distribution and box plot of a key numerical variable such as age, test score, and high school percentage. This distribution curve show how frequently each value appears. A smooth curve indicates the data is well balanced after cleaning. The transformation made extreme value less dominant. The box plot help identify outlier and the spread of the data. The central box represent the middle 50% of the value. The line inside the box show the median, and the dots outside the whisker represent outlier, which we removed earlier. This confirms that the dataset is now clean, consistent, and suitable for modeling. Now, I will explain about heatmap and PCA visualization. The heatmap display the correlation between variables. Darker color is indicate stronger relationships. For example, test score and high score percentage show a strong correlation with the admission status. Gender and city show weaker correlation, and this may help us identify which features are most useful for prediction. Principal component analysis, or what we call it PCA, is we use as to reduce dimensionality. The plot show the data set projected into 2 components. These 2 components capture 56% of the total variance, meaning they represent more than half of the important information. Points that cluster together indicate similar student profile. Clear separations help machine learning model classify patterns more effectively. PCA, or what we call principal component analysis, also confirm that our pre-processing step successfully reveal meaningful patterns.
On this slide, we present 2 important visual analyses, the correlation heat map and the PCA plot. First, the correlation heat map shows how strongly each variable is related to another. Darker color represents stronger relationship from the heat map. We can see that features such as test score, high school percentage, and some encode variable share meaningful correlation. This helps us identify which features are most useful for predicting admission outcome. Next, we have the PCA visualization, which reduces all variables into 2 main components. These 2 components capture most of the information in the dataset. The PCA plot allows us to observe clear pattern and grouping among students. It also confirms that the pre-processing such as scaling, encoding, and outlier removal successfully structure the data, making it ready for predictive modeling.
So this is our data overview after cleaning.